All right, this time we have 2 logs on one side, none on the other. However, because of this 2 here, we can't simply move one to the other side. We're not going to be able to isolate the logs on both sides. So remember that we have a property that we can employ here to take 2 logs and condense them into one. Because I do see that they have the same base, I can multiply using my product property to get rid of the addition and get everything into one log. So this will become log of 2x times x minus 5. You can either use double parentheses here, or you could use a bracket on the outside, however you want to write it. And that's equal to 2. Well, let's simplify this a little bit. Log of 2x squared minus 10x, and that's equal to 2. And now we're ready to swirl, but I'm going to go ahead and write in a little 10 there. Remember that common log is a log of 10, and I just want to physically have that there so I have something to circle. So again, left, right, center. So we can rewrite this as 10 squared is equal to 2x squared minus 10x. I see a quadratic. And so in order to solve a quadratic, we need to get everything on one side with a 0 on the other side. So I'm going to move 10 squared, which is also 100. I'm going to move that to the right with everything else. Remember that it's always good to keep your x squared positive. So I'm going to say 0 is equal to 2x squared minus 10x, and minus 10 squared is 100. And let's go ahead and keep solving. I see a GCF of 2, giving me an x squared minus 5x minus 50. And that's nice because now I just have a 1 as my a value, and I don't have to use guess and check. I can use my traditional factoring method, which says come up with 2 terms that multiply to be negative 50, add to be negative 5. So that's going to be x, let's see, minus 10 and plus 5 will give me this negative 5 that I need. All right, finally I can set each piece equal to 0. Remember that this 2 would just divide out since it doesn't have a variable there. You cannot just divide it out if it had a variable. You would have to set it equal to 0. So I have 10 minus, or x minus 10 is equal to 0. That's going to give me x is equal to 10. And then x plus 5 equals 0 will give me x equals negative 5. Now notice I haven't boxed either of those yet. When we're dealing with things where we might have introduced extraneous solutions, remember that we squared something, and so that might get rid of a negative that we had originally. We need to do a check on it. And the check that we need to do for a log is, remember that the log has a asymptote at x equals 0. And so the log doesn't even exist. The function doesn't exist anywhere to the left of that. And so in order to make sure that our function, our graph, would actually exist, we need to check it. And how do we do that? Well, we just need to make sure that whatever we're taking the log of doesn't ever go to the left of 0. So it's got to be greater than 0. So I want to go ahead and check that 2x is greater than 0 and that x minus 5 is greater than 0. So let's do that. The first thing I'll do is check the 10. So my check, I'm going to come up here and check that 2x is greater than 0. Well, for an x value of 10, 2 times 10 greater than 0? Well, yeah, it is. 20 is greater than 0, so that checks out. But I also have to check x minus 5 greater than 0. Again, for my value of x equal to 10, that'll give me 5 is greater than 0. That's also a true statement, so I can say that this one's good. Now, I need to go ahead and check my x equals negative 5. So I'm going to plug negative 5 in here now. So 2 times negative 5 greater than 0. Well, that's not true because negative 10 is not greater than 0. I don't even need to check this one. I could. Negative 5 minus 5, that's going to give me negative 10 again. But as soon as one of them doesn't work, then I'm done and I can cross that out and say that it's extraneous.